On this part of physics, we are going to talk about electricity. What is electricity? And what are the things related like current, voltage, which is potential difference, resistance, and power, energy, and also what is ammeter and voltmeter, Ohm's law, equivalent resistance, connection in series, connection in parallel, and some problems that are related to these ones. Okay, first point, what is the current? What is current now? Electricity. What is electricity here? As we know, we have a wire, and inside the wire here, the material that is used in producing wires, it has to be conductors. It has to be from metals. So this wire now, it has atoms here, and these atoms now have electrons. Each atom has what? Electron. And these electrons are bonded to their atoms, but they have they have a chance to move. They have what? A chance. So we have billions of these atoms inside this inside this wire. So what happens now when we make here a voltage that means like the electricity station, it gives you what? Voltage. And voltage is like energy that is trying to push these electrons. So when these electrons now are pushed by the difference in voltage, by the potential difference, these electrons will move through what? Through the wire. These electrons now are the electricity. So it's flow of electrons. And since the electron is very small in its charge, we use a big unit for the charge, which is coulomb. And one coulomb, it contains about 6.25 times 10 to the power of 18 number of electrons. So these number of electrons now are called what? 1 coulomb. And coulomb now is the unit of the charge. Okay, now how many coulombs now are moving in this wire per 1 second? This is what? The current. So the current, it's number of charges that are moving in a wire per what? Per 1 second. So over the time. So current now, it equals the total number of charges, which is Q, over the time that they moved with. So current, we can call this definition as the rate of what? Of a charge. Rate of a charge means a charge that is moving over what? The time it uses. So you understand now what is current. And the current, its unit is what? Is ampere. And this ampere is basic unit in physics. Basic unit from the 7 basic units and quantities in physics. Okay, now, this current now when it moves, will the movement be easy or not easy? It depends on what? On the wire. So now we understand that when there is a flow of electrons in a wire, what is pushing that flow is what? Is the voltage. The voltage is pushing these electrons to move. Now, we understand what is voltage, which is V, and we understand what is I, which is what? The current. And now what is R, which is the resistance. So now these electrons, when they move here, they have problem in their movement because they collide. While they move, they collide with what? With the atoms here, with the atoms of the wire. So the more the collision of moving electrons with the atoms of the wire, that means the greater what? The resistance. So resistance is like interruptions. Like interruptions for what? For the flow of electrons. So if this road was empty, the electrons will move easily. No resistance. They'll move what? Easily. So resistance, it is like interruptions that interrupt the flow of electrons in the what? In the wire. And this resistance, what is it? What is the resistance? The resistance here is represented by the collisions so that means imagine here you have a wire, and in this wire there are what? As you see, atoms. And now this is an electron. This electron now when it moves, as you see, it will be collected here, then it will move them back. then to be collected here, collided here, then to move here, then so that means it has many collisions. These collisions now will reduce what? The flow of electrons. That means it will reduce what? The current. So the current is number of charges that are moving in 1 second. So if they have higher speed to move, that means they have higher current. But now, due to many collisions of these electrons with the atoms, so that means the speed will be less. That means it will be decreased. So that means number of charges per 1 second will be decreased. So the current will be what? Decrease. So you understand now, resistance, it represents how or what is the amount of these collisions in stopping or interrupting the current from what? From movement. So this is what is called what? Resistance. So you understand now what is resistance, and its unit is what? Is ohm, and it is written like this here. And this one we said its unit is what? Ampere, and the voltage, its unit is what? Is volt. So you understand now what is the voltage, and you understand what is the current, and you understand what is what? The resistance in electricity. And these ones, main 3 parts in electricity. By understanding now all the electricity now, what is related to electricity in general depend on these 3 things: voltage and electricity and current, and also what? Resistance. All the other now points in electricity in general, it depends on what? On these ones. So understanding what is the voltage. Voltage, it is, we said, the energy that is used, or the work that is used to transfer a charge from a point to point. That means it's like energy to transfer what? The charges. So that means it represents like the push that is pushing the electrons what? To move. And current, we understand what is it now? It's number of charges that are moving in the wire per second. And here the resistance, we understand that it is what? The interruptions that interrupt current to flow through the wire. Okay, these ones now, these 3, how they are linked together mathematically as a law. Ohm's law here, the one who created this law, then we named the resistance unit after him, by the way. So he said that at a constant temperature, the voltage is directly proportional with the current. So that means at constant temperature, the voltage with the current, they are what? Directly proportional to each other. Then, as you know, if we have a proportional or a relationship that is direct proportional, we can change it into what? Into law by multiplying it by a constant. Then we multiply here by a constant. It's going to be the constant represented by what? By the resistance. Now it becomes this one what? This law, as a result of Ohm's principle. So voltage now, it equals the resistance times the current. The resistance times the current, and it is the most important here law in what? In electricity. Voltage equals resistance times current. And we understand now each unit of them. The voltage is its unit, and the resistance, and it is what? I. Now the relationship between them here now, what is the relationship here? Look, by increasing the voltage, we increase the I. We increase what? The I. So that means I, how is it affected by the voltage and by the resistance? The higher the voltage will be here, directly proportional if the resistance is what? Is constant. If the resistance is constant. And here, when we decrease the resistance, that means we increase what? The current, as the voltage is what? Is constant. So voltage and current, they are directly proportional, while resistance and current, they are inversely proportional. Okay, if we talk now about resistance, we said it represents by what? By the collisions that happen due to the flow of electrons. But here now, as you see, in each wire, we have a thickness. We have here cross-sectional area, cross-sectional, and we have length. What is the relationship now between the cross-sectional area and the length? Do they affect the resistance, do they increase it or decrease it? Yes. So look here, imagine now this is a road. This is the road now, and an electron is moving through this road now. And all this road, there are what? Atoms that they'll collide with. So the longer the road, the longer it will be hard for the electron to move. So that means if you make the wire long, what will happen for the resistance? The resistance will decrease. So that means now the relationship between resistance and the length of the wire. So if the length of the wire increases, what will happen then for the resistance? It will what? It will what? It will increase as well. It will increase as well. So the longer the wire, the greater the resistance. Why? Because it's going to be the greater the what number of collisions of these electrons, of these moving electrons with what? With the atoms. Okay, what about the cross-sectional area? What about the cross-sectional area here? If you make, for example, this wire wider, or the wire is narrow, will that affect the resistance? Yes. How? So the greater the area, the cross-sectional area of the wire, what will happen for the resistance? The resistance will decrease. Why? Because now if this wire is wide, so there are higher possibilities for the electron to move. So that means there is not only one way to move. That means it can move in many directions. So that means it can keep its speed higher. So that means the current will keep what? High in general. So that means when we increase the cross-sectional area, what will happen for the resistance? It will what? It will decrease. And our goal when transferring electricity through wires, our goal always is to reduce the resistance. And how we reduce the resistance? By increasing the cross-sectional of the wire as much as possible. So we understand now what is the relationship between the length of the wire and the resistance, and the cross-sectional area and the resistance. Is there any other factor that affects the resistance of a current? It is what? The temperature. So for example, now if we increase the temperature of this wire, what will happen for the resistance? Will it increase or decrease? Okay, if we increase the temperature of the wire, what will happen for the particles inside the wire? They will vibrate higher because they'll have higher energy. So this energy will be transferred from thermal energy, that is transferred from the heat or as heat. It will be transformed into kinetic energy. Kinetic energy, that means the movement of vibration of these atoms will be higher. So when they move higher, so that means now when there is moving electron here, that means it will have higher chances of what? Of collisions with the atoms. So in this case, the resistance will increase. So when temperature increases, also what? The resistance will also will increase as well. And also it depends the resistance or the type of the wire. So that means from manufactured material to another type of material that is used in manufacturing the wire. So that means some materials have less resistance and some has higher. And we have something called, for example, for conductors, superconductors. If this wire now is made from superconductors materials, in this case, the resistance will be about 0. So it will be reduced to be about what? 0 resistance. So that means the electrons move really on these wires without what? Without resistance. So that means type of material that is used for manufacturing the conductors also affects what? The resistance. So that means we have now, as you see, 4 factors that affect the resistance. Okay, if we now concentrate more now, we said we have voltage and we have current and we have what? Resistance. This one, its unit is voltage, and this one is ampere, and this one is what? Ohm. Okay, what are the meters that we measure their values? This one, to measure the resistance, we use ohm meter, and this one we use it what? Ammeter, and this one we call it what? Voltammeter. We call them what? Voltammeter. Okay, these ones we said they are linked in a formula that is voltage equals I times what? Times R. So in this case now, if you change it to be R, the subject, we get what? V over I. Voltage over what? Over the current. These ones now, how it can be then drawn? If I draw this one for Y, voltage, and for X, what? The current. Then in this case, the R, which is the resistor here, will be what? A line that increases as what? As V and I what increases. So the slope of this one here, the slope here of this line now, the slope of this line, it represents the change on X, which is V, the change on Y, then over the change on X, that is what? I. So the slope of the line here represents the resistance. If it comes a graph for you like voltage and current, and what they ask, what is the resistance? In this case, to find the resistance, just we divide the change in voltage over the change of what? Of the current. Related to the device that we use to measure the voltage and the current. So the voltage, we set it as what? Voltmeter, and it is like this voltmeter on the circuit drawn. And here, when we draw a circuit, we draw what? Ammeter as A on the circuit. Okay, if I have a circuit now here, we have a voltage as you see, and here you have resistance, and here we have a resistance as well. Then we go here, back to here. Okay, how do we connect the voltmeter and the ammeter? The voltmeter is to measure the voltage, while the ammeter is to measure what? The current. How these ones are connected into what? Into the circuit. Ammeter is connected in series, so that means you put the ammeter here, and in series that means it connects as part of the path of the wire itself. So ammeter is connected this way. That means if you take this ammeter away, there is no current will move through what? Through the circuit. While voltmeter, you connect it in parallel. What does it mean in parallel? So you put it here. This one now is the voltage. So if you take the voltage, if you take the voltmeter away of the circuit will keep what? Moving, because the connection of the voltage is in what? In parallel to the circuit. So you understand now voltmeter, voltage and its unit and its definition and its device that we measure it, and you understand that for the current as well and for the resistance as well, and also understand the charges that are moving in the wire and what electricity is. Okay, now we go to the second point, which is power. What is power? Okay, now when this electricity is moving through a wire, or these electrons are moving, or the charges are moving through a wire, we'll have energy and we'll have power. What is the power here? Power, as we know, in general, power, it equals the work that is used or the energy over what? Over the time it takes. And the power, its unit is watt. Its unit is watt. And here its unit is what? Is joule. And here its unit is what? Is second. And also we have another formula for power, which is the power equals I times V. I times V, which is the current times what? Times the voltage. Okay, this one here now, that means if I have a circuit and they gave us the current in ampere and they gave us the voltage in volt, and they are asking about the power, just they go to multiply them. If I take example here, now is a circuit, and in this circuit now, we said, for example, the voltage equals what? 2 volt. And here the I, which is the current, equals what? 3 ampere. What will be the power here? The power in this case, just you multiply the current times what? Times the voltage, 3 times 2, as long as they have the SI units. So that means it's going to be what? 6 watt. I hope that is clear now. This is for the power. Okay, as we know from a previous formula, that as we know, V equals I times R. Okay, if I substitute now this value instead of V here, what will I get? I'll get, as you see, P equals I times R. So that is going to be I squared times R. So that means this is now second formula for what? For power. So that means in this case, if they give you the current and the resistance, you use this formula to find what? The power. Okay, from this formula also, as we know, the I equals what? V over R. V over R. So if I do this one now again, here, as you see, P, it equals I times V. Okay, I leave V as it is, and I change the I by V over what? V over R. So when I put here now V over R, I'll get V times V, as you see, it's going to be what? V squared. So that's going to be V squared over what? Over R. So that means here it's going to be V squared over R. So this is now another formula also for what? For power. So you have 1, and here 2, and here 3, and here what? 4 formulas for power. When do you use these ones now? It depends on what is given on the circuit. Here, if they give me here, they give me here, for example, the voltage is 2 volt and the resistance is 5 ohm. And they are asking about what? The power. Okay, now what is given for me here? Resistance and also what? And voltage. Okay, what formula of power that has voltage and what? And resistance? As you see, it is what? It is this formula, right? It has a voltage and what? And resistance. So you go to find the power now by writing the voltage square, which is 2 squared. It's going to be what? 2 power 2, it's going to be what? 4. Over what? The resistance, that is what? 5. So then it's going to be 0.8 watt. So here now we find the power of any circuit based on what is what given. Is it the current? Is it the resistance? Is it the voltage? So we use these ones, and I help you memorize these for what? Formulas for all the questions to come. Okay, power, as we said, it is P equals E over T. And when you divide a quantity over time, it means the rate of that quantity. So we can define the power as the rate of what? The rate of energy. The rate of energy. Same thing, when we define the current, we define it as what? As the rate of charges, because it is over what? Over time. So you understand now what is power, and you understand what is the formulas, or what are the formulas that are related. Okay, here now we said the unit is watt, and here the unit is second, and here the unit is what? Joule. But sometimes in electricity, we don't use the unit what? Joule. We use as unit of energy. As unit of energy, we use, for example, here in electricity at our homes, when you get the bill of the electricity, it is written per unit. What is that unit? It is kilowatt hour. What does that mean? Kilowatt hour. And what does that mean? 1 kilowatt hour. 1 kilowatt hour is what? Is the unit of energy. Is the unit of what? Of energy. And as we know here, the unit of energy is what? Is joule. Okay, what does that unit mean? And how many joules it means? How many joules? Okay, here now for this formula now, if you get E, it's gonna be equals what? Power times what? Power times what? It's gonna be power times time. So that means the unit of energy, as a unit, it can be the unit of power, which is what, right? And also what? Times the unit of time, which is what? Which is second. So that means the unit of energy, it can be written like watt times what? Times second. And since this unit watt times second, it means joule. It means joule. So joule means watt times second as math. But since this unit is very small, how can we make it greater? To make it greater, this watt, we're going to change it to be kilowatt. It's going to be what? Kilowatt instead of watt. And kilo, it means 1,000 watt. And this one now, second, we're going to change it to be what? Hour. An hour is 60 times 60, which is 3,600 seconds. So now this one here now, it becomes a unit of energy instead of joule, but with what? It's a big unit. Okay, 1 kilowatt hour, it represents, now if I want to change it into joules, how many joules it represents? Okay, the K, which is kilo, it means what? 1,000. 1,000 what? Watt. 1,000 watt. Times what? Here it means times 1 hour. And 1 hour, it means 60 times 60 what? Seconds. Now, here in this case now, if you multiply 60 times 60, it's going to be what? 3,600, right? 6 times 6 is 36, and 2 zeros. Times what here? 1,000. And here, if you multiply the W by S, you're going to get W times S. And W times S, we said here, which is watt times it's equals what? The energy, that means it equals joule. So that means this one here, it means joule. So that means kilowatt hour, 1 kilowatt hour, it represents how many watt second? That means how many joules. Keep multiplying. Here you're going to get 3, 6, and here you get 3 zeros, 2 zeros. That means you get what? 5 zeros. And 5 zeros, you can write them like 3.6 times 10 to the power of 1, 2, 3, 4, 5, power 6. So this number now, as we said, is just 3.6 times 10 to the power of 6 what? Joules. This is number of joules that 1 kilowatt hour equals. So that means it's around 3,600,000 joules. 3,600,000 joules, they equal what? 1 unit of kilowatt hour. And this unit, now we said we use kilowatt hour as a unit instead of joules because joules is still very small. So now here, I think 0.18, which is 18 halala. 18 halala is the price of using energy. That is what? 1 kilowatt hour at our homes. So when we use our kilowatt hour, when we use this amount of energy, when we use 3,600,000 joules as electricity in our homes, we pay 18 halala for each. And it's different from a place to place and from a year to year and from a country to a country for how many or how much you need to pay for electricity for each unit of energy, which is what? Kilowatt hour. So we understand now what is power and what is energy and what are the two types of units for energy, which is kilowatt hour and also joules. And we understand what does it mean 1 kilowatt hour equals what. And now, as you see, in electricity, when it comes to our homes, it comes through what? Wires. And these wires now are extended for long distance. It can be hundreds, if not thousands, or also thousands of kilometers. And during that distance, the current that is moving, which is moving electrons, will face many collisions, as we said. That means there'll be a loss in the energy. For this long distance. So in order to reduce this loss of energy for long distance, that means we need to reduce the resistance. How we reduce the resistance? We reduce the resistance by choosing good materials in manufacturing what? The wires. This is number one. Number two, we try to increase the length of the wire. So instead of using a low cross-sectional area wire, we use what? Thicker ones, that they have larger cross-sectional area. This is number two. Number three, we need to increase the voltage. So that means the voltage, when we transfer the electricity from a city to another city, will not be the same voltage that we use it in our homes, like 120 or 110 or 220. No, it has to be to increase the lot in order to decrease the loss of energy while this electricity was transferred. Then we have transformers. When the electricity comes to the city, we have transformers that will reduce the voltage again. That voltage will be transferred into our homes. So that means to send the electricity for long distance, you need to decrease the resistance. And decreasing the resistance means decreasing the loss of energy. And how we do that? By choosing good materials for these wires when manufacturing, when they are manufactured, and also we increase the cross-sectional area of the wires, and also we increase the voltage as well. We increase the voltage. Okay, now we come to the third main point of this lesson, which is what? Which is parallel and series. That means electrical circuits. What is electrical circuits? Electrical circuit, this is now a circuit. Here, the circuit, that means it has a source of electricity, which is voltage. Then it contains resistance, and this one, how the resistance is locked. So that means this resistance here, if it is like this on a circuit, that means this one is, we read it as what? As resistance, and this one we read it what? As a voltage. And this resistance now, it means constant resistance. So constant resistance, we write it like this way. We draw it like this way. But if we write here like this, an arrow over the resistance, that means this one is movable. That means it's changeable, or we can change. That means this resistance, we can what? We can change its value, increase it or decrease it to control the current that is moving. So in some circuits, we have a constant resistance like this, and we have here a resistance that we can change it. We can change it to control what? The current. So circuit in general, as we said, we have here a source of electricity, and we have here resistance, maybe one resistance, maybe two, maybe three resistance. How many resistance? Then tell you what? Till you move back to what? To the source. So here we have what? Three resistance. Okay, you have different types of circuits based in how many paths for the current. Okay, the conventional current now, this high, longer side is going to be positive, and this one, it means what? Negative. And the conventional current will go from the positive what? Pole, then it will move this way. When it moves, that means it will move from this way, then this way, till it comes back to what? To the battery that is here. Then it keeps what? Moving during what? This circuit. And this resistance, it can be a bulb, as a bulb of electricity. It can be a bulb, and it can be a resistance that is added to the circuit. So while these electrons are moved, or this electricity is moved, as we said, we have current, and we have voltage, and we have what? Resistance in the circuit. Okay, number of paths that the current can move through, it represents that whether this circuit is parallel or series. So we have two types of connections. We have parallel, and we have what? Series. We have what? Series. Okay, what's the difference now between parallel connection and series connection? This here, how are these resistances, how they are connected into this circuit? If the path of the current is only one path while it's moving during the circuit, that means all the connections here of the resistance are series. Are what? Series. Series, that means they are one after the other. Series, that means based on how the current will move through them. So that means if the current moves through them one after the other one, that means the connection is here is what? Is series. So that means even if I have here a source of, as you see, battery, and I have here 1 ohm, then I have here another one, then I have here another resistance, then you move here another resistance, then you move here another resistance, then you move back to the battery. Here now, think of the current only. The current will move, as we said, from this here, the conventional current. When it moves from here now, till it comes back to this point, to this negative pole, how many ways it will move through? Regardless of the drawing, it looks parallel or it looks series. So series and parallel. Series, it means when the current is moving through the resistances one after the other one in one path. So that means this connection is what? We call it what? Series. So that means, as you see here now, as the current is moving, it moves through only one way it has. One way it has till it comes back. So that means it moves through the resistance one after the other one. So that means this type of connection for the resistances, we call it what? Series. Okay, what about parallel connection of resistance? If I have here a battery and I have here one resistance, then that, and I have also here another path, and here what? Another movement, as you see. In this case now, how many ways do the current have to move through the circuit? It can, so the current now, it can move this way, as you see, this way, then comes back to the original battery, or it can move through what? Through this way as well, you see? So it has two ways to move through. So that means since it has two ways to move, and in each path, there is what? There is a resistance. So this one now, resistance 1 and resistance 2, they are connected in the circle in what? In parallel connection. So now we understand what is parallel connection when the current has more than one path to move through, and we understand that series with only when the current has only one path to move through. Okay, have another drawings, then we just classify them as parallel or what? Or series. So these ones now, as you see, resistance number 1, number 2, number 3, number 4, number 5, all of them are connected in what? In series. Why? Because the current has only one way to move through the circuit. Okay, what about if I have this connection? Okay, what type of connection now for resistance number 1 and resistance number 2? Look now, when the current is moving through resistance number 1 and resistance number 2, will it move through them one after the other in only one path, or it will move through them in two paths? So we go now to analyze the current. The current now will move from here, as you see, it can move this one here. When it comes to this point, the current now has two ways, two paths to move, either left or right. And we said the current is the moving of electrons. So electrons now, they have two paths, either to go right or to go left. If they go right here now, as you see, they go here, then they come back here. So that is now they finished one path. And in this path, they moved only through one resistance. That means they didn't move through the other one. So that means since they didn't move through the other one, that means the other one now is connected with the first resistance as parallel connection. As parallel what? Connection. Now that means that you can move through as you see, another way for the current to move. And since these two resistances, each one is in one way, in one path of the current, so they are connected what? In parallel. So you understand now what does it mean series connection and what does it mean what? Parallel connection. Okay, if I have this type of connection, as you see here, I have here one resistance, then I go here, and I have here another resistance, and I go here and I have another resistance, and this is now resistance 1, and here is resistance 2, and here resistance 3. And also I have another resistance that is here, here. This one now is resistance 4, and here resistance what? 5. What type of connection here? Can I call it parallel or series connection? How do I analyze it? Look here now. We said we classify it as parallel or series based on the current. Look here now. The current now will move this way, right? And to move through this resistance. Then it will go back up here, like to this point now. Then in this point, whether it goes up or it goes straight, then it will be in both ways. It will move to this point, then come back what? To the original. So that means now I can say that resistance R1 and R3, since they are in the same path, because now whether it moves, the current will move from the upper part or the lower part, in general, it will move back to here, to this part. It will move, that means no other choice. That means it will move up, then to go either here or here, but in the end, it will be out from here, then to move through. So that means R1 and R3 are in what? Are in series. Are in series. Okay, what about now this one and this one? As you see, R4 and R5. R4 and R5, they are what? As you see, the current will move through them what? One after the other. So that means they are what? In series. They are series. So R1 and R3 are what? Series. And also R4 and R5 also what? They are in series. But now, what is in parallel? What is in parallel? Okay, look here now. If I have resistance in series like R4 and R5, if they are in series, I can add them to make them one resistance. I can add them and to deal with them like what? Like one resistance. So that means I can deal now, I can redraw this circuit as the following. I can draw it now as here resistance, and then they go up here, and here another resistance, then you go here another resistance, and I deal with this one here. These ones I can redraw them as one resistance. So one, and you draw only one resistance and back. So that means now this resistance here, it represents R4 plus what? Plus R5. So that means if resistances are in series, you can add them to make them one resistance, to make them now one resistance. Now this circuit now, it can be rewritten this way. Now, as I said, this one here, which is R1, and here R3, they are in series. Okay, what about these ones now? They are in parallel. This resistance that is here, and with R2 that is here, they are what? They are parallel. So I add them as parallel, but parallel, we have one way to find the equivalent resistance of what? Of the parallel. So then I deal with this one all as one resistance. I deal with these ones all as one resistance. So then I deal with the current that is passing from here, like it will move through this resistance, then this big resistance, then this resistance. So then I deal with these three as three resistances that are in series, that they are in series. Okay, now we have some examples here. If I give you here a circuit, as you see, this one is 3 ohm, and this one is 2 ohm, and here is 5 ohm. Then I ask you, what is the equivalent resistance? What does it mean equivalent resistance? That means the total resistance in the circuit here. It equals what? It equals now the total resistance. You add them. So you add 3 plus 2 plus what? Plus 5. Why we add them? Because the connection is in series. If the connection is in series, to find the equivalent resistance, just you add each resistance with the other ones. So that means it's going to be what here now? 10 ohm. 10 ohm is the total resistance. Okay, if the voltage here equals 30 volt, the voltage here equals what? 30 volt. What will be the current? What will be the current that is passing through the circuit? And we said the current now, which is I, it equals how many charges are moving in 1 second. How many charges? Okay, how can I find the current here? As we know, the current, it equals what? The current, it equals the voltage over the resistance. Now, which resistance I use here to find the current? I'm talking about the current that's moving through the whole circuit. So that means I have to use the resistance of the all what? Of all of the equivalent resistance, which is of the whole circuit. So that means what is the equivalent here resistance? As you see, it is 10. So that means it's going to be voltage, which is 30 over resistance. That is what 10. So that means it's going to be 20 watt ampere. In this case, now we find what is the current, since we have the voltage and we have what? The equivalent resistance. So in series, if the resistance are connected in series, to find the equivalent resistance, which represents the total resistance in the circuit, you add just these ones along. And you can, by the way, you can rewrite this circuit just to be like this. You can rewrite it like this. And here only one resistance. But what is this resistance now? You add these ones, as you said, they are 10. Then you write here what? 10 ohm. And you can here, and the voltage equals here what? 30. So that means, as you see, this circuit, it can be written rewritten this way. Then the current will be what? V, which is 30 over what? The resistance, that is 10. That gives you what? 20. So that means if you have many resistances in series, you can add them to make them one resistance, and you deal with the circuit as if you have only one circuit. So that means resistance, equivalent resistance in series, you add them, the first resistance plus the second resistance plus the third resistance, to find all of them. Okay, what about if they are in parallel? What about if these resistances are in parallel? How? So equivalent resistance in series, we said in series, equivalent resistance, it equals what? R1 plus R2 plus R3 and so on. Okay, what about if it is what? Parallel. What about if it is what? Parallel. What's in parallel here? What's in parallel? We said that the current has more than one path to move through. So here, we have here one resistance. Then back here. And also then we have also another path here. And we have here resistance. So this resistance now is, for example, 2 ohm. 2 ohm. And this resistance here is also what? For example, 2 ohm. What is now the equivalent resistance? What is the equivalent resistance here? That means what is the total resistance in this circuit? And as we know now, this one here and this one, they are in parallel because each one is in one path of the current. While the current is moving, right? The current here is moving. It has two paths, and in each path, there is a resistance. So these resistances are connected in parallel, regardless how the drawing is. As long as they are in two different paths, so that means they are what? In parallel. Okay, to find their total resistance, this formula, how to use it? To find the total resistance, 1 over the total resistance, which is equivalent resistance, it equals 1 over resistance number 1 plus 1 over resistance number what? Number 2. Okay, now if we apply this one here, this formula, we apply it, and our goal is to find what the resistance, the equivalent resistance. So that means I'll have 1 over the equivalent resistance equals 1 over R number 1, which is 2, plus 1 over the resistance number 2, which is also what? 2. Now, it's going to be 1 over R E equals 1 over 2 plus 1 over 2, which is half plus what? Plus half. Half plus half will give us what? Will give us 1. So that means now resistance, equivalent resistance, 1 over equivalent resistance equals 1. So flip them now upside down. So that means the equivalent resistance equals what? Equals 1. So here now you can redraw this circuit now, like here, and you have just one resistance here, and you can redraw it this way. And this resistance, you write it what? 1 ohm. Because this 1 ohm, it represents the total of these two resistances. Okay, you're gonna say, wow, how the two resistance, each one of them is 2 ohm, and their what? Their resultant resistance is only 1 ohm. That means less. Yes, I should tell you that. The equivalent resistance in parallel connection is always less than the smallest resistance. The resultant or the equivalent resistance in parallel connection is always less than the smallest resistance. While if the connection is in series, the equivalent resistance will be always greater than the greatest resistance there, because you add them. So here it's going to be what? So we understand now the equivalent resistance. If we have now the voltage here, 2 volt, that means you can find the current as what? V over R. It's going to be 2 over 1. That is what? 2 ampere. We understand now how to find the equivalent resistance and how to find then the current or the voltage that passes through it. Okay, last point we talk about is, if I have like this question now, the question says, in the figure, what is the total current that passes through the circuit? As you see here now, I have 3 resistances, right? Resistance number 1, which is 2 ohm, number 2, 1 ohm, number 3 is what? Is 2 ohm. And they are connected, as you see, parallel connection. So let me now to find the current. As we know, the current, it equals V over R. But which R? The equivalent R, the equivalent resistance. That means the resistance of all of them. Okay, how can I find it? Since these ones are in parallel, so that means it's going to be 1 over equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. So that means on this case now, 1 over the equivalent resistance, it equals 1 over R1. That means 1 over what? 1 over 2 here. 1 over 2 plus 1 over 1 plus 1 over what? 1 over 2. If you add them now, as you see, 1 over RE equals half plus 1 plus half. It's going to be what? 2. Now, this one, the 2 is not the answer. But because the 2, it means 2 over 1. In order to get the equivalent resistance here, you flip both sides. So that means you flip them upside down. So that means the equivalent resistance, which is R over 1, no need to write it, equals what? 1 over what? 1 over 2 ohm. So that means here now the equivalent resistance. So you can now redraw this circuit to be just like this. You see, 1 resistance back. What is this resistance? It is what? Half ohm. Done. So that means this now circuit is exactly equivalent to this circuit. Okay, now how can I find the current now? The current now equals the voltage, that is 12, divided by the equivalent resistance, which is what? Half. So I equals 12 over half. 12 over half will give you what? 24 ampere. So you choose 24 ampere as what? As the answer. We have another question here. Find the total current that passes through the circuit. How can we find the total current? Total current, as you see, we have the voltage. So total current, it equals voltage over the resistance. But what resistance here? The equivalent resistance, which is the resistance of all of them inside. Okay, now how can we find the total resistance? As you see, this one and this one, they are in series. They are in the same path of the current. While these two, they are in parallel. So these two that they are in parallel, I solve them first. And I find the total resistance, the equivalent resistance for only this part alone. So now this one is going to be 1 over equivalent resistance equals 1 over R1, which is here 2, plus 1 over R2, that is what? That is 3. So now 1 over equivalent resistance, it equals 1 over 2 plus 1 over 3. If you make same denominator, you multiply it by 3, by 3, by 2, by 2, you'll get what? 5 over 6. Now, you flip both sides, so that means equivalent resistance equals what? 6 over 5, which is then it's going to be 1.2 ohm. Now, can I redraw this one now? This one here now, 1.2 ohm, it represents the resistance here, which is 1.2 ohm. You see, so that means now I deal with this part, all of it, as one resistance that is 1.2 ohm. Now, how can I find then the equivalent resistance? Now I add them. Because now this part now, and this part now, and this part now, they become in series, so we add them. So equivalent resistance here now, you add the first one 0.8, and the second one, which is 1.2, and the third one, which is what? 4. So that means it's going to be 2 and 8, it's going to be 2 plus 4, it's going to be what? 6 ohm. So that means now this one here, 6 ohm, is the total resistance in all the circuit. And we said you can redraw this one here as just like this here, and you have here 1, and you have here 1, and you have here what? 1. This one is 0.8, and this one 1.2, and this one will be what? Will be 4. Then you can redraw it again as just, you have what? One resistance only, that is equals what? 6 ohm. So that means this circuit, it can be redrawn this way or this way, it means the same. So here now for the final one here, this is 24, and the total resistance is 6, right? So that means define now here, it equals, now what is the voltage? The voltage is 24. You divide it by the total resistance, that is what? That is here 6. As you see, it gives you what? 4 ampere. So the answer, you go to choose what? 4 ampere as the answer. So you understand now how to deal with parallel circuits and series circuits, and you understand if the circuit is like this one here, where you have parallel and series at the same time, we understand. Okay, last point just we need to understand. Last point we need to understand is the current when it moves from here. If I have here and here I have okay, here R1 and R2, as you see, they are in series. They are in series. So if the current here is 5 ampere, while the current is moving through this way, will the current be changed? Will the current be changed in all its journey? Will it be changed? No. So that means no change in what? No change in current. No change in what? In current for this part. No change in current. So the current in series will not be changed. It will remain as it is, 5 ampere in all the circuit here. Okay, what about the voltage? The voltage, if the connection in series, it changes. Keep that in mind. It is what? It changes. So the voltage in series, it changes, while the current does not change. And here is the opposite. So the current here, what? It changes. Why does it change? Why it does, or it changes? Why? Because the current now, when it moves from here, it will change. That means the current that will move from here will different from the current that will move from here. So that means the current will not remain the same, because it will be separated. It will be separated in two ways. So that means the current, as long as it is parallel, it changes, while the voltage what? Does not change. No change in what? No change in voltage. If the connection is in what? Is parallel, no change in voltage, and there is a change in the current. I hope we understand here. Okay, if I have here, if I have a bulb here, and I have here 2 bulbs, and this is now, as you see, circuit. This is now a circuit, and here I have another bulb, for example. So here now, what would happen? What would happen if this bulb now burns out? If it burns out, what will happen for the brightness of these ones? As long as the connection, as you see, parallel, so that means the voltage will remain what? The same in this in this 3 what? Parallel lines. The voltage will remain the same. So the brightness of this bulb and these bulbs, when this one burns out, will remain as it is with the same what? Intensity of brightness. Okay, if I want to cut this one here now, if I want to break this circuit, if I want to break it, if I have one chance to break, either to break it here, or to break it here, or to break it here, or to break it here, which point I can break the circuit, or I can cut the circuit, then there is no current moving in the whole circuit. Okay, what will happen if I cut the circuit from here? So that means you eliminated this path. So that means it doesn't mean the current will stop. No, it will keep moving from this way or this way, and it comes back. Okay, what about if I cut it from here? It still have one path here, one path here. But if you cross the current from here, so that means in this case, wherever the current is moving, either from here or from here, no way to go back to the source. So in this case, all of them will stop working, all the users. I hope now you understand what is related to electricity fully. Then you can solve now the questions easily on the quizzes. Thank you.